All right, welcome everyone. It's almost time to get started. So let's wait a little for everyone to actually get a seat. I can't really see you. That's good. That's good. That's probably more important than the other way around. Although it's more important you actually see the screen than you see me. But well. All right. Well, first of all, thanks for coming to this session today, in which we are going to talk for the next 60 minutes about infrastructure as code, and then especially the three tools that I see used most when doing infrastructure as code on Azure, which are obviously then Bicep, Terraform, and Pulumi for me. So we're going to go through each of these tools. I'm going to show you a quick demo so that everyone has at least a little understanding of what each of these tools actually does and what they look like. That's especially handy if you've seen one of them, used one of them, but not the other, then you can compare the two. So we're going to start with that, and then we're going to look at the differences and where they are equal and the pros and cons of each of these tools. So my name is Erwin Staal, and I'm an Azure architect from the Netherlands. I work for a company called Xspirit, and I live in a beautiful town called Assen, which isn't really famous for anything but the Motor Grand Prix. So if there are any Motor Grand Prix fans, like in a month, there's the TT of Assen, the tourist trophy, and that's probably the only thing that we are sort of famous for. In the Corona pandemic, when we couldn't do this speaking in person, etc., a friend of mine called me and asked me if I wanted to help write a book, and so we did. So with the three of us, we wrote a book on Bicep. So the book covers Bicep, obviously, but also covers how you actually use infrastructure as code to manage your entire environment on Azure. So it's not just the Bicep syntax, but it's also how do you do policies on Azure? How do we structure things? How do we do permissions? How do we roll out our infrastructure? So there's a chapter on Azure DevOps and a chapter on GitHub Actions, etc. So if you, after today, think that your next project should be done using Bicep, well then this book might be something for you. All right, so today we are going to talk about these three tools. And let's start with a quick introduction of each and every one of them, and then we quickly dive in and do a demo of each of these tools. So let's start with Bicep, which I find to be the easiest one to learn and to get started with. It was created by Microsoft. It's the youngest of the three, and you could say that it was created by Microsoft as a replacement for what we had in those days, which were the ARM templates. And if you ever worked with the ARM templates to create infrastructure, then you probably know that they were quite horrible to work with. You used to write them in JSON, which isn't the best language for such a thing. So the files would become quite lengthy, would be hard to read, hard to maintain. And if you actually wanted to try to modularize your infrastructure, try to do some reuse, etc., then it became really hard. You had to do all these funky things to make it actually work. So Microsoft saw that and came with Bicep. And as you will see in a bit, that's very different from ARM templates and much, much easier to get going with. It's a DSL, so it's a domain-specific language that was created by Microsoft for this specific purpose. And that is one thing that it has in common with Terraform, because Terraform is also a DSL, but that was created by a company called HashiCorp in 2014. So it's the oldest of the contestants that we talk about today. It has its own language, it's a DSL, which is then called HCL, the HashiCorp Configuration Language. And one of the powers that it has is that it just does not only allow you to modify and create stuff in Azure, like Bicep does, we will see in a bit, but allows you to create stuff in all sorts of platforms and services out there. Last but not least, I added Terraform CDK on there as well. Terraform CDK is a version of Terraform that allows you to write code using C#, for example, and then have that being transpiled into Terraform code and have it deployed. We are not going to talk about that today. And the main reason for that is that it's still in the early days of their product. If you go to their website and look up Terraform CDK, you see that it's version 1.0, whatever. It's in preview. They actually state that you should not use it in production, etc. So we're going to skip that one today and just use the HCL that was available from 2014. All right, last but not least, we're going to cover Pulumi. And Pulumi is completely different in the sense that Pulumi allows you to build your infrastructure using a tool of your choice, a programming language of your choice. At least if it's one of the programming languages that's listed there. And .NET actually stands for C#, Visual Basic, and F#. So if any of these programming languages is your favorite, then you can actually write your infrastructure as code using your favorite language. And it was created by Pulumi in 2018. So it was named after the company that actually created it. All right, let's do a quick demo of each of these to see what they look like, so you at least have a bit of an idea if you haven't touched them at all. All right. How is this in the back? Is it readable? Is it good? I think you're doing a thumbs up, but it's hard to see. All right, so we're going to start the demo with Bicep. And the only thing that you basically have to do if you want to start out with Bicep is install the Azure CLI, because there's Bicep in there these days. Log into your Azure subscription and install the extension on VS Code. So that VS Code really starts helping you building your infrastructure. What you then do is create a file that ends with the .bicep extension, and you can simply start to create resources. And one of the things that you can do is use the built-in templates that you get from the extension. So if I actually start typing store, then you see that there's a template for a storage account, and I just hit enter, and all the stuff that I need to fill in to actually get it to work by default is there for me to do. So I can actually use tab completion to go over each of the fields and fill in the parameters. One thing that you might notice directly is that if you do use these templates, they sometimes tend to use a bit of an old version of the API in Azure. So the line above, the first line, is actually how you state which resource you want to create. So you start with the keyword resource, because you want to create a resource. Then you give the resource a name. And then you state what type of resource do you want to create. It's a storage account in this example. And then you tell it which version of the API in Azure you actually want to use. And what we see here is that it's quite an old version that they use in the templates. It doesn't get updated that much. So what you also can do is just start typing yourself, hit resource. We call it STG for storage account. Let's find the namespace for storage account. And then it automatically lists me all the versions that are available on this particular API. And I can just grab the latest. Another feature that we now get from the extension is the required properties option that you see shown here. If I now just hit enter, you see that the extension gives me all the stuff that I need to fill in that is required to deploy the resource. All the other stuff on the storage account is optional, but this is mandatory, you need to fill it in. So we can actually give it a name and always do something like this because it needs to be unique, etc. That obviously needs to go in some kind of location. Where's US is fine. There's actually Copilot helping me here, which is quite convenient. Another thing that I really like in this extension is that it can also help me with these kind of things. So a storage account, this Q, has a list of properties, of parameters that you can actually enter in it. It's a defined list. The extension knows that and actually shows me what options there are, and I can simply pick one. The same is true for the kind. I want to do a storage account v2, so I can easily click it. If I would make a typo here, it would also normally actually give me a red squiggle underneath it and tell me that this is wrong and I should pick one from the list. I don't actually know why it doesn't do that, but all right. Let's revert it. All right, so this is how you simply create a first storage account. So you do see that underneath the West US, it actually gives me the orange squiggle. So it thinks there's something wrong here. And it says I should probably create a parameter for location, because you should not hard code a location in your templates to make it more usable across regions in Azure. So I can easily have it create a parameter, and a parameter is a way to add input into your template and make them more dynamic. So you can also do things like add a description, as you see over here, which you would then see when you call this particular template. And with things like stating the West US, you can give it a default value instead of always having to pass in this parameter. Like putting something in a template, you can also get something out of the template and then reuse it later on. That's been done using the output parameter. And that could look something like this. No, that's Copilot going wrong. I think it's actually properties, primary and primary endpoint dot blob, something like that. All right. So this is the syntax for returning something from a template in Bicep. You just use the output keyword, and then using the dot notation, you can actually use the resource that you just created to get a property from it and get it returned. All right. Next, what you want to do is get this thing deployed. So what we're going to do, we're going to go into the correct folder. And deploying a template, at least from your local machine, is done using the Azure CLI. The command is something, let's see if I can find it, AC deployment. Yeah, looks something like that. You use AC deployment to tell you when to do a deployment. You say group, because you want to deploy to a resource group. You could also use AC deployment subscription if you want to deploy to a subscription. You do a create, you want to create something. It needs to go into a particular resource group, and you need to tell it what template you actually want to deploy. And the last thing you see here is the what if option, what if parameter. That is actually optional. You can leave that out. And if you leave out the what if, then the deployment will just happen right there, right now. But I always like to be able to see, and then make a change to a template, what that change is actually going to do in Azure. And that's exactly what the what if can do for me. So I leave the what if in there. And what it will now do, it will try to compare my template to whatever is in Azure, in the cloud, and show me the results. And then normally for a search account should not take too long. All right, there we go. So what it now did, it came back to me with the result of what it's going to do, and it shows in green what it's going to create for me. If a resource would already exist, it would use a red color for stuff it's going to delete, and it would use orange for stuff that it's going to change. So it allows you to easily see what it's going to do for you. The thing is, however, that the what if option is sort of newish, and they actually already tell themselves that it might actually produce false positives and some noise, etc. So that's a bit of a pity. The other two tools, as you will see later on, do a bit better here. Though the results that they give are actually the results as they should be. But apparently for Bicep, we cannot fully trust on what's happening here. All right. That's a very small example of Bicep. Let's move into one for Terraform. So Terraform is slightly different in getting started. You need to install the Terraform CLI, and there's also an extension for VS Code, which isn't that good compared to the one for Bicep, but there is an extension that helps you with a bit of the basic syntax validation, etc. So if you want to get started with Terraform, we need to do a few things. We start with a Terraform block in which we can configure a few things. One of them is defining a required provider. And we are obviously not going to do anything on AWS. So we are going to replace that with Azure. Let's see what it comes with. Actually, I think we are on 3 point something. So what I need to do here is actually tell Terraform with what environment, what target I want to talk to. Where Bicep only talks to Azure, you can use Terraform to talk to all kinds of different things. We will see that in a bit. But this is how we tell Terraform with what target we actually want to talk. What you can also do is tell Terraform that you want to have a required version, which is something like 1.11 or something. It's probably going to tell me that it's wrong, but we'll see. And this allows you to tell Terraform which version it should at least use deploying your stuff. So there is an important thing here about versioning between Terraform and Bicep. In Bicep, we saw that we could define the version of the API that we wanted to use on the particular resource that we are going to create, in this case, the storage account. That is different in Terraform. In Terraform, you tell the version you want to use on the level of the provider, which covers all the stuff that you can actually create and manage on Azure. So the actual version of the storage account API that's being used is kind of hard-coded within that version of the provider. So that means that sometimes those versions might actually be a bit out of date and need to be updated to support the latest and greatest features that are available in that API. Microsoft actually does most of that hard work, but if something is missing, you can actually create a pull request since it's open source. But it happens from time to time that a particular feature, a particular property on a resource is missing in the provider, simply because they used an old version. So that works slightly different here. All right. Now that we have that in place, we do need to do a bit of additional configuration on the Azure provider. I'm not entirely sure why, because this is all you have to do. This feels like a bit of a default value to me, but still you need to put it in there, otherwise it will fail and complain that you haven't done so. So we put it in there. The smart people behind this, they probably have a good reason to do so. All right. Now we can actually start creating a resource. So let's go out and create a Azure RM storage account and call it SDG. There's no support here for templates and whatever. I did install a few extensions that should actually do templating for Azure resources, but they weren't that good. Most of the stuff I just use Copilot because it works better than most of the extensions that I actually have tried. So this is then what that same storage account that we just saw in Bicep actually looks like in Terraform. It looks kind of similar. The feel around the language here is kind of identical. But the extension, like I mentioned, doesn't support things like telling me which account tier values are available, etc. All that stuff is not available in this extension for Terraform, where it is in the one for Bicep. All right. Just like with the with Bicep, we can also use input in Terraform, and that's been done by actually creating a variable instead of what in Bicep we call a parameter. And this is actually doing the same thing. And now I can say var.location. I'm gonna put a hard name in here because I didn't create a resource group. Something like that. And just like in Bicep, I can also output something again to the outside world. For example, the endpoint or something. Is it gonna help me? Yeah, something like that. So as you can see, that's all kind of similar. We can again use the dot notation to get a property from the resource that we just created and output that again to our caller. So if we now actually want to deploy this thing, then the first thing we need to do is a Terraform init. There we go. 146. I always forget about these numbers. Let's see if this is any better. All right, so with a Terraform init, Terraform is gonna do initialization, obviously. And one of the things it's gonna do is download the provider, the Azure provider, to my local machine. It downloaded it here in a folder so that it can actually use the provider when it needs to deploy something. And then we can do Terraform apply. And Terraform apply is a command that actually goes out to my Azure account and see what it needs to do. Will probably work. All right, so just like the what if in Bicep, Terraform is now going to go out to my Azure environment and see if it can already find a resource group with this particular name and if it needs to change anything or update or whatever. And it's going to come back with the results and ask me if I want to actually apply that, if I think those changes that it's going to make are actually correct. And there we go. Just like we saw in Bicep, it's also going to give me back what it's going to create using the green color, etc. And I can verify that, and I can then hit yes, and it will actually start deploying this stuff. All right, let's move on to our final contestant, which is Pulumi. Let's move into that folder. And creating a new Pulumi project looks quite similar, at least when you choose the C# version, for how you would actually create a normal C# project with the .NET CLI. This time you can actually do something like Pulumi new. Yeah. So we can run Pulumi new Azure C#, and it will then start scaffolding a new project, a C# project, which has a bit of default Pulumi stuff in there, as we will see in a bit. Let's give it a name. Let's give it a description. And now it asks me for the name of a stack, and it suggests that I should use dev. And you could probably, for now at least, compare a stack with an environment. So this is a dev environment, and we can also have other environments. It wants to have a location, fine. And then it starts scaffolding my project. And as you can see, it starts installing dependencies and etc., downloading them like you would also see on a normal C#.NET project. So what it did for us is actually create a C# class in which resources are being created. The entry point is this run async method that will be called whenever you start deploying this infrastructure. And then creating infrastructure is actually just like creating newing objects. So this is how you would create a resource group. And then this is how you would create a storage account within that particular resource group. So you can just use your normal development flow like you would just to build your infrastructure in your favorite language. And as with the other tools, you can return some data to whoever was starting this deployment, which might be you on your local machine, or which might be your deployment pipeline, etc. And of course, you can also use input in the form of parameters to make modules, for example. All right. If you then want to deploy this Pulumi application, you again use the Pulumi CLI. Not in there. I think I removed something. Yep. All right. We can say Pulumi up. And now it's gonna, as you see, it's gonna build my application like a normal .NET build. It's gonna run it. And just like Terraform, it's gonna do a sort of plan to figure out what changes it needs to make inside of my environment. So you can see it's gonna create a stack. And that stack will be created in the Pulumi environment. And then it's gonna create a resource group and a search account. And if I would now hit yes, it will actually start creating that stuff, etc. All right. I'm not sure where that one came from. All right, so that was a quick introduction to each of these tools to give you a bit of an idea what they actually look like and how they compare a bit how you actually get started with any of them. let's talk a bit more about that plan stuff. That each of these tools can actually first go out to your environment, figure out what needs to change, and actually tell you what it is going to change. So in my current project, they found it a bit scary that we would just push infrastructure to production without anyone approving that. So what you can do, now that tools like Terraform and also Bicep and Pulumi can give you back what it's going to change for you in its environment, you can use it actually in your pipelines to do approval flows. So that's what we did here. We first asked Terraform to plan and to show us what is going to change in our Azure environment. And in Azure DevOps, you can actually then upload those results and view them in the Azure DevOps portal. And after that, you can just hit apply if whatever is in there looks good to you. So if you want to, this also allows you to do nice things deployment-wise. All right, now that we looked at a bit of the tooling, let's move on to what tool fits best in your situation. And one of the things that you then might want to look at is, am I gonna just manage Azure, my Azure environment, or is there more that I need to manage? Am I going to do multi-cloud stuff? So Bicep here is on the single cloud side of the equation. Bicep can only manage stuff within Azure, not anywhere else. There is a preview to do stuff within AKS, and there will be a preview to do stuff on Active Directory, but it's also in preview, and that's how far as it goes. Whereas the other tools, Bicep and Terraform, allow you to manage much more than just Azure. There's obviously the other cloud vendors, but there's much more tooling out there that you can actually manage and configure using these tools. So for example, we can do stuff in Active Directory, like creating groups and permissions and whatnot. We can configure stuff in tools like GitHub or Azure DevOps, create repositories and projects and set permissions in it, etc. We can go to New Relic to create our dashboards, alerting, whatever. From the same tool, we can configure tools like Databricks, like I'm doing on my current project, or set DNS records in tools like Cloudflare. So that opens up a whole world of tools and SaaS vendors that you can actually configure with these tools, which Bicep cannot. And then there's this other thing on Bicep, and that is that Bicep is actually good in talking to what we call a control plane in Azure, and not so much the data plane. So for who doesn't know what the control plane and data plane are, you could basically say that the control plane is what creates and manages the resources in Azure, your infrastructure. And then the data plane is what creates stuff within that infrastructure. So to give you an example, you can perfectly use Bicep to create a SQL server and a SQL database on Azure. But you cannot use Bicep to create a user in that particular database on Azure. You cannot talk to Active Directory just yet. So it's just the infrastructure level, not what's inside of the resources. And depending on what you do on the cloud, that might be fine, or not. Depends on what you're going to do. All right, so how can the other two tools actually do that? How can they reach out to so many other providers and get them configured? They do that through what we call the providers. We already saw the Azure provider in the first demo, but there's much more providers out there for a lot of different systems. And there's official providers that are being managed by the vendor of the platform that you're trying to manage. And there's also community built providers that you can just grab from the repository. They are distributed as plugins. It's just plug and play. You just import them into your code and start using them. And a differentiator between Pulumi and Terraform is that what Pulumi did when they started out back in 2018 is that they started using the Terraform providers. That was a really clever idea because then they could quickly start letting you use a programming language and still talk to all those providers that Terraform already could. But the thing is, we talked about that versioning stuff where some providers in Terraform lag behind if it comes to newest and latest versions. And Pulumi also saw that. So what Pulumi did was they used the Terraform providers, but they now also have a few what we call native providers. For Azure, for example, they regenerate their provider every night from the API from Azure. So that's always up to date these days and doesn't no longer use the Terraform provider. That's what we call a native provider in Pulumi. All right. What Terraform and Pulumi also have in common is that they need a state file. And in this state file, they save information, they store information on what the world looks like according to them. So in this particular example, you see a bit of version information on Terraform itself, and then you see that I created a resource group in Azure, and that it stores all the information on that resource group in the state file. And that state file is being used during deployments, etc., to see what has changed and what not. As I said, Bicep does not have a state file. You could say that Azure is its state, but it obviously doesn't work anymore when you do more than just Azure. So the other two tools have state files. Terraform by default creates a state file locally on your desktop when you start deploying stuff in a local state file, which is JSON, as you see in the example here. But when you start working in a team, that doesn't work anymore, so you need to store your state file somewhere remotely, for example, in an Azure storage account. Pulumi also has a state file, but they do it a little different. By default, Pulumi stores the state file in their SaaS offering. So if you start out with Pulumi, you create an account in their SaaS offering to which you log in using the Pulumi CLI, and then they store the state in their environment. But the thing about state, especially for Terraform, is that since every single detail of your resources is being stored in that state file might also, or will probably, contain secrets, or personal access tokens, or passwords, etc. This is an example of a Terraform state file in which I created a secret in a key vault. And that value that you see over there is the actual value in the vault. It's not a hashed value or whatever. That's actually what I generated. That's the plain text value of the password of that secret. So secrets are plain text in state files in Terraform, in the JSON files like you see over here. And for Pulumi, that's a bit different. At least when you use their SaaS offering, they will encrypt that state file, and they will manage the encryption keys, etc., for you per stack. So they handle that for you. You obviously need to pay for that, but they handle it for you. Otherwise, you need to do it yourself. That means that if you, for example, store the Terraform state file in Azure in a blob storage, for example, you need to take care of the security of that storage account. You need to lock it down. You need to make sure that only the right people can actually access that state file, etc., etc. All right, let's look at a few other demos in which we look at, there should have been a window here. This one. All right, other window. In which we look at how we can actually use these three tools to configure something else but Azure. So how can we use the providers in these tools to actually do something interesting? And where I said that in Bicep you can only talk to Azure and nothing else, I kind of lied. But I'll explain it. I think it's okay. So what I'm doing in these three demos, I'm creating an app service in Azure, and I am configuring a DNS record in Cloudflare, my DNS provider, to actually get a proper URL to that app service that I am creating in Azure. So I'm doing that in all these three demos, which is obviously slightly different per tool. So Bicep is all fine with just creating the resources in Azure, just the app service, etc. That all just works fine. But then I need to configure something in Cloudflare to configure my DNS. But I said that Terraform cannot talk to anything else but Azure. There is a way around, and that is using a resource type which is called deployment script. And a deployment script allows you to run a PowerShell or Azure CLI file or script when you run your Bicep stuff. So what I did here, I created a PowerShell script that actually goes out to the API of Cloudflare and starts configuring my DNS record. So that is a way, a workaround, I think, to actually do something outside of Azure. What happens here under the hood, if you start deploying this, is that in Azure, they will start spinning up a container instance for you, deploy a container to it, and run your PowerShell script within that container, and then kill it. But the problem is that you cannot connect that container instance to your private network, for example. So that means that if you need to configure a resource that's within Azure, that's been locked down, your SQL Server, for example, then you actually cannot access that one from a deployment script. So there is a sort of workaround. You can do scripting, but it's kind of limited, especially in enterprise environments where no one is going to allow you to go to a SQL Server over a public URL. So back to the point, Bicep doesn't support anything else but Azure. All right, let's move on to Terraform. In Terraform, it looks like this. The first two resources that I create are, again, the standard Azure stuff that we already saw. It's the service plan and it's the web app. And the start of a resource, that always points to the provider that you are using to create that particular resource. So down here, you see that there's a few resources that actually start with Cloudflare. So this is how you can, in Terraform, talk to something else, use a different provider, just by using a different resource type. And it all looks quite similar, right? I didn't have to go to a different programming model or whatever. I can just do the same thing. There was one more thing that I obviously needed to do to get this to work, and that is in my setup file, tell it that I now also want to use the Cloudflare provider and what version, etc. And obviously, you also need to connect to Cloudflare. You need to authenticate. And in this example, that is done by setting a API key as an environment variable. And then Terraform will pick up that environment variable and log into the API of Cloudflare. So it's basically quite simple in Terraform to start targeting different services by just adding a provider, making sure you can authenticate, and then use the resources within your templates. Last but not least, how does that work for Pulumi? In Pulumi, this is how you can, for example, create an app service plan and then the app service on top of that. Looks quite similar to the storage account that we already saw. Nothing new, nothing fancy here. And this is what it looks like if you then, for example, want to create a new record in Cloudflare. You can just use their SDK to do that. So what I had to do, I had to add some usings on the Azure stuff, and in my CS podge file, instead of only pointing to the Azure native provider that we were already using in the previous demo, I now also add the Cloudflare provider, which is just a package that comes from NuGet, like we are used to in .NET. So that's basically the only thing you need to do in Pulumi to start targeting something else. Install the right SDK, and then obviously log in, which is done in the same way as in Terraform, and then you're good to go. All right. Let's stick a bit with Pulumi here. Because what I find really interesting on Pulumi is obviously that I can use my standard programming language that I am using day to day anyway to create my infrastructure. And I think that's really powerful compared to learning a new language and doing stuff in another way. Because it allows me to treat my infrastructure as I do my normal stuff. So that means that I can use my favorite IDE to do the work. I don't have to learn something new there. I can use all the power of that IDE to do refactoring, write tests, and all that sort of stuff. I can use the same monitoring and logging tools that I do for my normal application, and I can actually debug the creation of my infrastructure, which is something that you cannot do in Bicep nor Terraform. But in Pulumi, I can actually just set breakpoints on my infrastructure and see what's going on when I create the stuff, which is especially useful, obviously, when it goes wrong. And another thing that you can also do is have applications create infrastructure. I once worked on a project where we had a UI built for a client, and part of that application was that we needed to create SQL servers and SQL databases in the Azure cloud for the client. The client needed to be able to go into the UI, say I want a new environment, and a database had to be created. What we did then, back in the day, was deploy ARM templates from C#. You can do that. It wasn't that hard, but you can do it. But it would have been much better if we could have stayed within C# and used Pulumi to actually create these databases. Would have been a much nicer flow in the application. And if you even think further on that path, what you now often see is that there's a whole notion of platform teams popping up. These teams are teams that build internal developer tooling to enable other developer teams. And we see them build internal tools to self-servers, to give a bit of self-servicing to the other DevOps teams to make their lives easier. And what we see happening is that people start building UIs in their favorite UI language, like Blazor or whatever you want to use there, and then start creating and configuring all these different systems from that application, building their own custom workflows, and managing stuff in GitHub, in Azure DevOps, creating basic infrastructure in Azure just to quickly get a new team up to speed and get them going. And that is something that we can easily do with Pulumi. All right, how much time do we have? 20 left. All right, should be good. Another interesting distinction between the two is where your code, your templates, are actually being executed. So for Bicep goes that if you deploy a Bicep template, then the template is actually being converted back into an ARM template. That ARM template is given to Azure, to the Azure Resource Manager in Azure. And that will start processing the templates and give you a result. So it's being processed there on the Azure cloud. The other two tools, on the other hand, the processing happens on the local machine. That might actually be your development machine where you are developing your templates. And otherwise, there's probably going to be your build agent where the execution is actually happening. And that's interesting because it allows all sorts of scenarios that you couldn't do with Bicep. We already talked about building custom workflows. But there's also simple things like I once run into the fact that I set permissions on a key vault in Azure. And setting the permissions actually quite quickly returns a 200 OK as I'm done. But the actual permissions aren't active yet. And sometimes that's a pain in the ass because you need the permission to be active in further steps down in creating your infrastructure. And in Bicep, that then simply fails. If you run it again, it probably works because by then the permissions are active. But in the other two tools, you can cope with that by, for example, do a retry, or for example, just wait for a bit for those permissions to become active. And we all hate waiting, etc. But at least there's a workaround to get it done, which you can do because it actually runs on the client. All right. Another thing that you might want to look at when choosing between any of these tools is not just how does my IDE support it, how is the language working, can I do interesting stuff like loops and whatever, can I do the complicated stuff, but also what tooling is available around the tool, the language that I actually pick. And then you see a few interesting things. All of these tools are perfectly fine supported by the most known deployment tools out there. So you can just use Azure DevOps, GitHub Actions, Circle CI, whatever, to get these tools deployed. There's no problem there. But if you look a bit further at other tooling around, then you do see a few differences. If we start with Bicep, then we see that there's a bit of tooling to get you going in terms of scanning for best practices, doing security scanning, linters, etc., etc. There's quite a few tools available which work actually pretty good, which is nice. For Terraform, Terraform is by far the winner here. There's much more tooling out there for Terraform around actually also writing tests, generating documentation, support for Git pre-commits, etc., etc. For who doesn't know Git pre-commit, by the way, if you do Git commit on your command line, then an event is being triggered, the pre-commit, and you can actually hook into that event like a webhook, you could say. So just before the actual commit happens, you could run a few tests if you want to. And there's a lot of support for testing Terraform stuff right before you do the commit to prevent you from doing commits that actually contain bugs or vulnerabilities, etc. So that's really cool, really powerful. And Pulumi is clearly lacking here. I didn't find much tooling around Pulumi to actually do vulnerability scanning, etc. on that code. Obviously, you can actually use your favorite testing frameworks, right? You can actually use whatever you use to do your testing, unit testing, for example, like you do on all the other code. You can perfectly do that. And of course, there's tooling around there, like SonarCloud. And SonarCloud can perfectly scan your C# code. But the thing is that SonarCloud is not going to tell you that if you create a key vault using Pulumi, that you probably should enable TLS 1.2 or whatever. Those infrastructure-related things aren't going to be covered by the particular tool. So Pulumi is kind of lacking here. All right, the other thing you might want to look at when you pick one of the tools is, am I actually the only one using that particular tool? Or can I find some support in the community for the tool I'm using? And then interesting stuff actually happens. If you look at Stack Overflow for the tags, Terraform, Pulumi, and Azure Bicep, then these are the numbers of questions and answers that you actually get. So you can see that Terraform is by far the winner here, with over 16,000 questions and at least 17 asked today, which is 2 months ago or something, but all right. And Bicep is also kind of okay, and Pulumi is also lagging behind a bit, but they're kind of similar. But the thing is, both the Terraform tag and the Pulumi tag aren't Azure specific. They are or could also be around other providers, and especially for Pulumi, they could be around different programming languages than the one you are actually using. That might be okay. I mean, if someone gives an answer in TypeScript, then you are perfectly capable of translating that into C#, but maybe not. So that's something to keep in mind. And Bicep obviously is always Azure. So if we zoom in a bit and get the specific tags for just the Azure-related stuff, because there's also tags for that, then especially on the Pulumi side, things start to get a bit worrisome. Terraform is kind of okay, but there's quite a few things happening on the Pulumi side there. It might be fine, since there might be a lot of answers in different providers and programming languages which you can use, but it's something to keep in mind. We kind of see a same pattern when we go to Google and look at the Google search trends for each of these tools. So this is when I search for the Google search trends for Terraform, for Azure Bicep, and for Pulumi. If you, by the way, search for Bicep and not for Azure Bicep, that's going to give you a completely different result, obviously. So you have to be kind of specific here. But then this is what you see. Terraform is by far the clear winner, and you can't even differentiate the other two, right? So what I did, I zoomed in on just the other two, and this is the last 5 years. And this is then what we see for both of these tools. And you obviously see that Bicep starts somewhere a bit later. It's a bit newer than compared to Pulumi. And then we see that Pulumi is apparently searched for a bit more than the search term Azure Bicep. There were actually a few people already searching for Azure Bicep apparently before it was actually released. So I always wonder whether people from Microsoft who already knew it was coming, or whether people doing lift and shift from their on-prem data center to Azure and trading their Bicep in Azure-related form. I don't know. I find it interesting why that happens. Maybe a typo or whatever. All right, so if you then return to the office on Monday and start to do a project with any of these tools, which one should you then pick? And obviously that depends on a lot of things. And I hope I showed you in this talk that there's quite a few areas you could actually think about when you want to move to any of these tools. But just to quickly go through them, I find Bicep to be the easiest. It's quickest. I find it to be quickest to learn and the quickest to teach to others. The extension in VS Code, etc., is really, really good. So the developer experience is really good. That also goes obviously for Pulumi, right? You can pick your favorite programming language, your favorite IDE, and that's gonna by far outperform in terms of developer experience compared to the other two. Multi-cloud is obviously a very important differentiator. If you need to do multi-cloud, or if you need to configure multiple systems, at least multiple software as a service offerings, then Bicep is not for you. Then you probably want to go to any of the other two. And the main differentiator for Pulumi, obviously, is the fact that it's code. And you actually get to write your infrastructure using your favorite language. That also means that you actually need to be able to write proper code in that favorite language. I mean, just like normal code, you need to be able to create and write structured code that is easy to manage. You probably need to do testing. You probably want to do like things like inversion of control, whatever, to keep it maintainable in the long term. So you need to be able to actually use the power of a programming language to be able to do that in Pulumi, which might be really, really useful when you are a DevOps team that's end-to-end responsible and who's doing C# or whatever already. And another clear differentiator for me is that build your own workflow, create infrastructure from an application perspective. If that's what you need to do, then Pulumi might be really useful. So you can just stay within a single tool instead of having to go to something else to create the infrastructure in the Azure cloud or any other software as a service offering. So these are the things that I would keep in mind when figuring out which tool is best for your next job. So with that, we've come to the end of my presentation and what I wanted to get across. There's a few links to things where you can find me if you want to ask questions or contact. If you scan that QR code, you are being sent to the latest edition of the magazine that we as Xperit create twice a year. We usually create a new magazine around Techorama, Belgium, and Techorama in the Netherlands. So twice a year we create a new one. And in that magazine, there's an article that covers some of the stuff that we've been looking at today. So if you want to reread some of the things that we talked about, you will find an article in that magazine on the same subject. So with that, we've come to the end. And I want to thank you again for being here. And I wish you a nice conference.